Welcome to the third part, guys. We'll be discussing about the React component lifecycle using the class-based component syntax. So here we have our app component, and in this tutorial let's learn what phases a component in React has to go throughout its lifetime. So we can understand this very easily through the help of this very lucid diagram that I found on React.js website. So in broader sense, a React component goes through two phases. The first one is render phase and the second one is commit phase. So in the render phase, React computes or basically calculates the changes which are supposed to be done by comparing the return from the render method of the current state to the render method of the next state it is going to be, in response to any changes that might be happening due to the change in either the prop or the state. And only when it decides what needs to be changed, that's when it enters the commit phase. Inside the commit phase, it basically make actual changes in the DOM nodes in the actual DOM and applies those changes, which makes it visible on the browser in our UI. So there are three phases of a component lifecycle. That was about the reconciliation, render phase, and commit phase. Now let's talk about the lifecycle. So the component goes through three lifecycle phases: the mounting, updating, and unmounting. So mounting happens for the very first time when we use our component in some other component. So for example, here we have our app component being used here inside the index.js. We are straight away mounting it onto the root of our application. And the very first thing that's going to be done is, so since this is a class, it'll be instantiated by the whichever component we have referred into, and it'll get called. So if I put a log here, it'll be the very first thing to get called, and the next method would be component did mount. Component did mount gets called when it's actually get rendered in the DOM. Mounted. And if you see now here, so constructor gets called first and then mounted gets called first. So why constructor being called twice? Because the methods that are present in the render phase, they can be called multiple times by React because they belong to React internal housekeeping. But we can make sure that it's guaranteed that the component did mount will only be called once. So you should avoid making any side effects inside the constructor function. So by side effects, I mean you shouldn't call any. You shouldn't make any API calls inside it. If you want to do that, make sure you do that inside the component did mount. And constructor is a very good place to initialize your component state. So this is how you initialize it in a class-based component. So for example, we want to increment a counter on an interval of 1 second, and we want to update our state. So for example, here inside the component did mount, I'll do something like this. This dot timer equals to set interval inside the this function body at an interval of 1 second, or let's say 2 seconds. I want to change the state. I want to trigger a state change here, and which will trigger the update phase of our component. And here I want to update the counter by 1. This dot state dot counter plus 1, right? And after every 2 seconds, this will get called and this will update our state. And let me listen to the changes here. This dot state dot counter. So now if I see the output here, so after every 2 seconds my counter will get updated. The next lifecycle method that we might want to have a look into is one of the hidden methods here, and that one is get derived state from props. So this gets called in both the mounting phase as well as the updating phase. So suppose we have this use case wherein we want to change the way we are getting the prop inside a component and then render it. So for example, if I'm getting this hello from index as a greeting property inside our app component, and I want to transform it before rendering it. So for example, I want to convert it all into uppercase before rendering it. So I can do something like this: shout greeting. I'll initialize it to blank. So we can use this method called as get derived state from props, which does exactly what it says, and it accepts two parameters, props and state, which returns the new state that we might have. Counter is what we are going to get from the state variable itself, and shout greeting will be our transformed version of our props.greeting, let's say to uppercase. Now we are doing a string transformation here. It can be extended to any kind of transformation. For example, you're getting a list of you're getting an array of items, and you might want to mutate it before using it in your component because it was passed in a way that wasn't aligned with the way you were expecting it in your component. So this type of function can be really helpful in that case. So now instead of binding this props.greeting here, we can use this state.shout greeting. So this is how it looks right now. The next lifecycle method that we are going to discuss is should component update, and this particular lifecycle methods can help us tap into the React re-rendering process to control the way we want to re-render a component. So your component could get updated either due to a change in a prop or due to a change in one of the state variables. Now there could be multiple props and multiple state variables, and you might want to tell React that only when this particular prop changes or this particular state variable changes, only then re-render my component. In all other cases, just don't re-render it. Now this particular method is sparingly used, and this is the sole purpose of this method is performance optimization. So you might not be using it very frequently, but let's discuss it. So it takes two arguments. One is next props and next state, and it is a predicate function, which means that it returns a boolean. So which means if you simply return false from here, which you should never do, if you return false from here, it won't ever get updated. So whatever was there, whatever result was there from the mounting phase, it'll keep that. So which means it has now become a static component. Even when the state is being changed internally, those changes are not being reflected here because we have stopped our component from getting updated, from getting re-rendered, recommitted basically. Now we definitely don't want to do that, and rather we want to apply some conditions, apply some checks to make change only when some condition is met. So for example, we want to stop updating our component when the counter reaches 4. So we can do that by next state dot counter is less than equals to 4, only then return true, or else return false. And let me update the counter to 1 second here. Okay, so this says that when the upcoming state variable is either less than or equals to 4, it'll keep on updating it. But as soon as it becomes 5, which means after the 4th iteration, it won't render, it won't update the UI. So we have 1, 2, 3 and 4. So it has stopped here now. So this is how we can control the mechanism of our React component updation. The next method we are going to talk about is component did update. So let's see. So the method component did update gets called whenever our component changes have been committed every time either some of the prop or the state change. So which means we'll have a reference of the, so our new props will definitely be available on the this.props or this.state, and the previous props and previous states we get in the form of these variables. And then there exists a third parameter that has been recently added called a snapshot. We'll see that in a moment, but let's see what's happening here. Previous props, let me just copy this. So this get called whenever the component updates, simply. So we see when it was 2, this was there. So when it was 2, the previous props, the previous state was holding a counter value of 1, and shout greeting was this, and this was the previous props. So as you can see, the prop is not changing at all, but the counter variable is updating by 1 as we have written. So here what we can do is, so the use case of this particular lifecycle method is, for example, some of the prop changed, some of the prop provided to this component changed in the parent component. So assume this component was a user component which is rendering the user details by getting the user ID as a prop from the parent component and making an API call to a remote server and then showing the UI to you, showing the JSX. So suppose the prop, there exists a prop called user ID, and that is not matching to the new user ID that we have got as an effect of changing in the prop from the parent component. So that's when maybe we want to make an API call, right, with this particular new user ID. This is our props.user ID. For the sake of brevity, I'm using this syntax, and we have got this new user, and in response to that we want to update our state asynchronously when we get that new user. So this is one scenario which in which this can be really helpful. So we're listening to a prop change and performing a side effect when that happens. So this is the right place to do all those things. The next lifecycle method we want to discuss is get snapshot before update. Now this lifecycle methods, the output of this method gets passed as the third argument to the component did update method here. Now the use case of this lifecycle method is very limited. So for example, you have a list of elements present inside a container, a scrollable container, and a new elements get pushed into it, and you might want to restore the scroll position during this transition. So as you can tell, this lifecycle method is just present at the border of the render phase and the commit phase, which means when the commit phase is just about to commence, it'll we can tap into the process for storing any last minute snapshot, after which it will get updated to the new DOM. So the way it works like is this: get snapshot before update. It accepts two arguments. Again, we have the previous state and the previous props and previous state, and here we can check if, for example, previous props dot items dot length is not equals to this dot props dot items dot length, then maybe calculate the container scroll height and scroll top maybe, and return it. Let's say it was 100 pixels, so we'll return 100 from here, and then we can, after the component gets rendered actually on the DOM, we can update its position here. So for example, if snapshot exists, then we can do something like this: dot container ref dot scroll top equals to snapshot, right? So that's how it can work. Let me just comment it to see how it works. Let's see the output in the console. So we'll simply get the third parameter as 100, nothing else. Okay, so that was about the get snapshot before update method, and the last method that's left is the component will unmount method. Now this method gets called whenever we, as it says, whenever the component gets unmounted, whenever the component gets destroyed. Now that could happen when maybe due to some condition your component is no longer available on the DOM, or the most common use case is when you navigate, your component is present on a separate route, and you navigate away from that route, so that's when the component gets unmounted. So simply this is a perfect place to, for example, we started a timer here in component when the component mounted, and now when the component is unmounting, you might want to clear that timer. So we can do something like clear interval this dot timer. Similarly, this could be a place wherein you want to cancel any AJAX call that might have been happening, and the component started to get unmounted at that time. Or you might have subscribed to some events like a WebSocket or some observable, and you want to unsubscribe to them from now to free up the memory resources. So this is a perfect place for that. So that's about all of our React component lifecycle methods. In the next video, we'll see how we can implement these using React hooks.